and especially to the organisers. You're doing an excellent job. And I want to pick up where Richard left off yesterday, thinking of George Odell and Tom Lloyd. If it were not for those two people, many of us would not be here today. And if we think about the bitter fights that many of them were involved in, it is a privilege to be in such a convivial environment here in the beautiful city of Rome with all of you. And I think they could even be a bit proud of all of us for doing what we're doing and sharing our thoughts with each other. So today I'm going to talk a bit about use traces and research design, and then I'm also going to deviate a bit, tackling the bigger questions, which you may or may not. So John Shea is a colleague of us that also did a lot of experimental work, and I quite enjoy some of his work, and he's got a lovely sense of humour. And last year he published some advice from Uncle Screwtape. And he said the production of stone tools with sharp cutting edges is a uniquely derived hominin adaptation. In the long history of life on Earth, only hominins have adopted this expedient and effective strategy. Thus, flaked stone tools are irrefutable proof that hominins were present at a particular place and time. There's every reason to expect that insights gained from studying stone tools should provide important information about the course of human evolution. And yet, one senses that archaeological analyses of stone tools are not making as much of a contribution as they should to the major issues of human origins research. Now, most of us are involved in small-scale projects, short-term projects, and when I use the term use traces, I include macrofractures, microwear, and residues. They are all traces of use. Now, these small-scale projects, it's very good to establish interest among students. We can assess old or new methods, and we can contribute contextual knowledge to sites or assemblages. But they are seldom able to contribute meaningfully to the major issues in human origins research. This usually requires long-term dedication and the development and integration of knowledge, skills, methods, and theoretical frameworks. Now, I argue that most meaningful answers or explanations come from the questions that we ask, not necessarily the methods that we use. When methods are carefully chosen because of their potential to provide convincing and multi-stranded evidence, the most valuable and lasting results are obtained. Now, last year again, our colleague Bruce Hardy, together with Marie-Helene Mansell, published this work of Neanderthal use of fish, mammals, birds, starchy plants, and wood between 125 and 250,000 years ago. And they followed the integrated approach. And here you can see striated polish that is associated with fish processing and a piece of fish scale. They looked at 182 tools. Now, Bruce Hardy has already been at this for at least 20 years. And aligning that with the stratigraphy of their site, they can make predictions or put up hypotheses for things such as hide working, butchery, woodworking through the sequence of their site. You will see one bird here. I would question that. We need to see more birds before we can say anything. But at least we can start hypothesizing about bird processing at that point in time. And this work, together with other works from other disciplines, is starting to change the way that we view Neanderthal subsistence behavior. The work of Fiona Rolls. She has been busy with it for at least 12 years, or I don't know, has it been longer? I think at least 12 years Fiona has been busy with this. She's producing some of the oldest direct evidence for hafting. And her work is especially exemplary because she continues to make the experimental work and cross-refer to experimental work and what she sees on the archaeological tools. And recently, they've also started to include residue work together with the use trace work. And here you can see a resinous residue and most probably an imprint of the plant twine that was used to bind this tool. Some major issues from Uncle Screwtape in human origins research relate to behavioral and cognitive evolution. For example, Fiona tells us that when hafting can be shown as integrated into tool production processes, it reflects an organized behavioral pattern. And of course, it is very important that we can see that very early on. Stan Ambrose argues that composite tool manufacture marks a considerable increase in technological complexity compared with single component tools. It places greater demands on integrating working memory with prospective memory and ultimately constructive memory. And all of these things is what make us human and modern thinking humans today. So direct and unambiguous use trace evidence of hafting has the potential to inform on levels of cognitive and behavioral complexity. Whether associated with Neanderthals, early Homo sapiens, or other hominins, tracing evidence of hafting through time and across space is an important endeavor for those of us who work on assemblages older than 40,000 years ago. And designing thorough research projects and developing the appropriate skills around this issue will almost certainly pay off in the mid-term, especially for younger students, people starting out now. There will be opportunity and money if you start focusing research in this area. But this is not the only major issues that we can contribute to as use trace specialists. There's the origins and spread of domestication, environmental change and human adaptation to that on many levels, symbolic mediation and or ritual, and even the evolution of language. Well, at least some of us will try and we'll see what comes from that. So while we are busy with our respective small projects, each on our own continent, it might be worth our while to keep these issues in the back of our minds. And similar to a microscope, we can keep on zooming in and out. And as long as we're conscious of these global debates and arguments, we can start feeding into them. We need, however, to realize that not every small-scale project can contribute directly, but sometimes they can feed very effectively into more extensive long-term research programs, explicitly aimed at contributing to current debate. Now the fun part starts. At least I think, and for me, as many of you will know, I'm fascinated by the evolution of hunting technologies. And that's why I usually write about hunting weapons, because I go and look for them. Not necessarily because I'm interested in behavioral or subsistence behavior. But I think we may be able to start thinking about the evolution of human cognitive and behavioral flexibility by using some of the information that we gain from hunting technology. Now, when I started out on my journey about 10 years ago or so, it was still widely accepted that Middle Stone Age humans were foragers and scavengers unable to hunt effectively, and you have the same situation in Europe with the Neanderthals. And at that time, most of the residue work was focused on plant residues and reported on plant residues. Somehow, however, this did not quite correlate with what we were seeing in the archaeological record. Here you can see a stone point embedded in the vertebra of an extinct giant buffalo, Glacis River, around about 100,000 years ago. I was also fortunate enough to do my graduate studies with Lynn Wadley at the wonderful cave site of Sibudu. And We have beautiful stratigraphy at the site. It's one of the best dated Middle Stone Age sites. And we also have excellent organic preservation. These are blow-dated bones from a layer dated to 64,000 years ago. Then at 58,000 years ago, one day I was excavating, and this is what was coming out. And you can see the mandible here of a medium-sized antelope, stone point, and resinous ochre. And that stone point sits right here, dead shot, immediately. So simply the archaeological and use trace evidence did not support each other. And that made me realize that we cannot be too complacent ever about our methods. And that if we become too comfortable, we may miss a lot of information. So what is necessary to investigate hunting from a use trace perspective if I see that with my own eyes in the site and everybody else reports on starch grades on those tools? Well, first of all, I need to know whether the tools were hafted. With a stick in one hand and a stone in the other, I cannot accomplish that. Then I need to know whether that morphological type works well to tip hunting weapons. And if so, what are the traces that can be expected on them? Clearly, I would expect to see macrofractures. Many experiments all over the world have shown us fractures happen. But fractures, even diagnostic impact fractures, is diagnostic of impact, not of hunting. Okay, so it can only be an initial step to see whether an assemblage has the potential to be hunting weapons. I still need the microwear to support that. And if I am lucky enough to work on a site with preservation and I have the residues, lo and behold, then we can tell a story. So naturally, my approach to research design was integrated. The theme that carries this workshop this week. Now together, the three approaches are mutually supportive and constraining. And that means that if some traces tell a different story than the other, I need to start over again. Then something is wrong. But when they all tell the same story, we can have a relatively high level of confidence in our interpretations. So of course, I had a couple of energetic guys. We made the tools. We went hunting in the African bush. The tools work. They work well, and when they break, they do a lot of damage in the animals. So we had a reference collection. We could look at the breakage, residues, and very importantly, at the distribution of usewear, residues, and fractures on tools. I think we did about 50 tools in that experiment. We also did some blind tests. Now, these were controversial tests. However, I learned a very valuable lesson with these first tests. When I started out, my tutor told me that plant cells are square, they have double cell walls, and sometimes you see small starch grains in them, they're translucent, and they're birefringent. And I went happily along with this. Confidently, I can recognize plant from animal. So what do you think I interpreted that as when I saw it during a blind test? Now, the blind tests worked like this. My supervisor one day just came into the lab and gave me 2 bags of tools and said, "Annelies, you tell me what I did with them, period." And I tried my best. This is striated animal tissue. It's highly birefringent, it's translucent, and if I play around with a microscope long enough, I can even see starch grains around them. In fact, I've never seen anything without a starch grain. So, collagen fibers, and the work of Brigitta showed us very clearly that we can now have a solution perhaps for these, but compared to plant fibers. So I went to the animal histological publications and taught myself animal histology, and I realized that in fact there's a lot of animal residues that are highly birefringent, translucent, and have some of the properties that we use to identify plant materials. I also decided that never again I will see an isolated trace as meaningful. I did over the years 4 blind tests, all with various levels of flaw, one deeply flawed, yet, as I say, we learned valuable lessons from it. But after those 2 blind tests, I said to Lynn, I don't want to look at anything that you controlled anymore. If you want to give me a blind test, go onto your beautiful game farm in the Limpopo province in Africa, do whatever you want to do with the stone tool, or don't do anything, whatever you see fit, and do it in the way that you think Stone Age people would have done it. Trying to do these things under controlled situations is not helping me anything. I'm not interested in recognizing residue or usewear on a controlled sample. I want to know whether I can figure out what somebody did in the field, in a real actualistic situation. And these are the last 2 tests that we did, and so it all averaged out around about 82%. However, blind tests are not about testing the skills of analysts. And today I want to encourage you not to be scared to do blind tests. They are most valuable in highlighting methodological and or interpretive shortcomings. The learning process through blind tests is incredible. Don't be scared. Put yourselves out there. Go and do them. Don't see it as a test for yourself. See it as a test for your technique, for your equipment. Test it until the technique breaks down, or until you can say, okay, it works. Okay. Because this helps us to develop and grow our own discipline. And if we don't recognize our mistakes, our flaws, we can't grow and we can't learn from that. So okay, now I've told you a lot of negative stuff, and oh, have to test and nothing works and it's all a big mess. So how can we counteract the fact that not everything we see on the tool is use related? Or that in isolation some traces appear very similar? First, we need to understand that not all samples are appropriate for analysis, especially residues, but also usewear. We have to have caution, especially about material from open-air sites, or curated material, of which the curation is not unknown. Looking at a hand axe of at least 1 million years old lying on the African landscape, and then throughout that 1 million years washed down into a cave, became embrectured, had to be hammered out, is perhaps not the best thing to study for residue analysis. Okay, we have to be realistic about what we do and about what we can say about these things. Secondly, we need to understand that when use traces preserve, they never, ever, ever preserve alone. You never find a collagen fiber on anything that any of us have experimented with on its own. Okay. These things, when they preserve, and there's a lot more going on, and we'll get to that a bit later. Thirdly, we need to understand that our equipment, what our equipment can or cannot inform about. For example, our microscopes and magnifications. What I see looking at something at 20 times, 40 times, even 100 times, is completely different than what I see when I look at 1,000 times. Or yesterday, one of you demonstrated a microscope up to 5,000 times. It's like looking at the night sky with a pair of binoculars compared to the photographs that we see from the Hubble telescope. Okay, So when we use low power, and by low power I mean 100 and less, we have to say that and be candid, that we can only say certain things about what we see, because there's a whole world beyond that 100 times. Sampling, great thing. If I do a macrofracture analysis, and I write my protocol and I say my sampling is all the complete tools in the sample, is that macrofracture analysis? No. It's only use fractures that I'm looking. You have to look at all the broken pieces of a morphological type to do a macrofracture analysis. It's about fractured pieces. The trace type. Some people like to only look at edge damage. It informs somewhat, but it can never tell us really whether something was hafted or used in hunting. What about the surface of the tool? And we all know that a lot of damage happened through trampling, and Richard used the example so nicely of the little tools in a baggie, and I've got my ochre and my little piece of hide and all my stuff I'm carrying with me, and there I go. These things knock against each other and I get edge damage. So I do not say that we shouldn't do these things, especially in small projects, but we need to be honest with ourselves about what we can say and what we cannot say when we do certain things. I usually do a feasibility study before I do any large analytical work, and it saves a lot of time and energy and resources. So if somebody comes and I say, okay, I'll look at your tools, I select about 10, and then I look for potential preservation and distribution patterns. And I accept that if traces seem random, they probably are. And it means that I have no or limited interpretative value. Okay, I'm an impatient girl, so then I move on to the next sample. Not everybody is as fortunate as that, but we have to be realistic that not everything can be analysed in the way that we ideally want it to. So what convinces me? Multiple occurrences of a single-use trace type. If I see collagen, I want to see it 5, 7, 50 times on a single tool. And I want to see it co-occurring with supporting traces. If I see collagen, I want to see blood, I want to see bone, I want to see fat, I want to see hair, I want to see animal tissue. And then I go back and make my tick and count it as collagen. I also want to see it in non-random distribution patterns on several tools of similar morphology from a single archaeological context. Okay, if I look at stone points with this shape, and I see animal residues on this portion, I want to see it at least on 5 tools on a similar place. And then we can start telling a story. So I record all use traces on each tool. And sometimes it does take me up to 5 hours. And it seems like madness. But with the method that I use, I feel that it creates the best possible qualitative and quantitative data to work with. So this is a little quartz tool as big as my thumbnail, and I plot everything that I see on that. 8 macrofractures, 24 microwear sets. So microwear set will be a striation set in the direction that the striation is on the tool. Polish occurrence, and those are the microwear traces. 35 residue occurrences, for example, resin, animal tissue, fat, animal tissue, and that's what my plot looks like. That gives me a total of 67 use traces to reconstruct an interpretation from on a single tool as big as my thumb. Also, I like to see what happens on the ventral side and what happens on the dorsal side. It's one of the best ways to assess trampling or any post-depositional stuff is that usually the traces will differ on the 2 sides. But if it was used as a hunting tool, the same thing happens on the back and on the front of the tool. So use traces quantified according to morphological characteristics of the tool type and expressed in percentages can generate comparable data on inter-assemblage level. This is usually what my data sheets look like, and I still work in old Word things and actually write it by hand before I put it in the computer, but I've seen Kate doing much more sophisticated stuff. But it does mean that I can, these are my different porsches on the tool, each with a ventral and dorsal side, ochre, plant tissue, plant fiber, and I can count the occurrences. The same with use traces. Now, I know it's not exact, and to quantify any of the work that any of us do exact is, I think, not quite possible or realistic. But it does give me a very realistic reflection of what is actually happening on the tool. And if we look at a case study, 35 back tools from Sibudu, and this samples all the back tools that was excavated at that point in time, so no sampling bias whatsoever. They all came from one context dated to within 4,000 years, and in the Middle Stone Age that's good enough for us, and from one industry, the house and spoor. I excavated them myself, put them in the baggie as they go, nobody touched them. I take them to the lab. On this sample I recorded 1,826 residue occurrences. Now that gives me the possibility to do this. So I can generate real data. These are the animal residues, and we can see high occurrences of animal residues on the bladed sides of this tool. And if I do the same with plant residues, I can see that plant residues are concentrated along the backed edges of my whole sample of 53 tools. And if I summarize it, I can immediately see that the plant material came onto those tools from a totally different origin than the animal material. And then we can start talking about hafting, what type of hafts and what these tools were used on after they were hafted. So with this approach, the white noise is filtered, presenting as outliers, and interpretations are based on sound representative data. It generates data that can be statistically assessed. Now, okay, I know this is archaic. I haven't figured out another way. You young people can try to do it differently. I just do the old chi-square, and I actually still do it by hand because I can never get the computer stuff to work. So it's quicker for me to just do it. Okay. But for the Sibudu segments, I could show that there are statistically significant differences between the observed distribution patterns of micro-residues on the sample and those that can be expected if all things were equal. And we took all the different residue types through this and could show this. Thus, the probability of distribution patterns occurring coincidentally as a result of contamination, selective preservation, or post-acquisitional or excavation damage can be rejected for the sample. Doesn't mean it didn't happen on one or two of them, but when we look on the sample, we can be rather confident that this is what we can say. Back to my hunting story. So, we excavated the upper layers at Sibudu, and for the Sibudu industry, we've named this new, and that publication will be out shortly, and the final MSA. I'm pretty sure I used my method, macrofractures, microwear, and residues, and that means I'm pretty sure that several of these stones, at least half, were used as spears. It does not eliminate other use. Okay. In the meantime, back to the hole and we continued excavating. And the next industry is the house and squirt industry with the notorious small-backed artifacts. And I've already told you something of what was happening there with animal and plant residues. But we also found that these tools were hafted with a resin and ochre recipe, glue recipe. The micrograph above is resin and ochre of some of the experimental work that Lynn did, and that was included in one of the blind tests. And this is what I see on the archaeological tools. And luckily, Sipuru, very good to us. Often we can see it with the naked eye, that there's ochre on the back of these tools. And it's very often in combination with resin. And here you can see on that sample how the ochre and resin, the distribution patterns are very, very similar to each other and concentrated on the back of the tools. But, and there's always a but and a dilemma with us, that distribution pattern didn't bring me anything because it could have been hafted in any of these ways. And I won't know that. So, how do we figure out whether these tools could have been used for hunting and what kind of hunting weapons? Again, a student, Justin Pargeter, and he just wrote to me this morning. He's been accepted at Stony Brook with John Shea, so I'm very glad, and the experimental work will continue. Made some tools, very crudely, but in most configurations they work more or less well for hunting. And the different configurations had different pluses and negatives, but they all, you could go hunting with any of those. That gives us a new morphological sample of the replicated flint tools that we could compare with archaeological tools on a macrofracture level. And eventually I'll get to the microscope work, but time is not always there. Justin is continuing his work with trampling, and this is in Malawi, a trampling experiment. And here we show diagnostic impact fractures, and this is the result that he got on the trampling material, usually 3% or less. And these are over the years different people doing experiments and using the same criteria for exactly the same fracture types is what we get on the experimental hafting. Hunting tools. So this means that when we do macrofracture analysis and we use the 4 diagnostic impact fractures, we need to take into account that there's a 3% that may be accidental. So if your percentages are very low, careful. Now, if something is trampled, we usually expect that it's trampled from the top and it's lying flat on the ground. But Justin, very astutely, recorded how these tools change direction in a trampled environment. And that means that the impact is very similar to napping impact or any other kind of impact, whether hunting or anything else. Now recently, Carl Hutchings has been doing some interesting work, but in very fine-grained material. And Justin and I will start working with him on quartz material to see if we can replicate his results on quartz material from Africa. The problem, however, is that there's a huge overlap in the different ways, so it's still diagnostically difficult to say whether something was a spear or whether it was knack or whether it was used as an arrow. But I think it has potential, and we will explore this further. But at the same time, I want us to just take a moment to reflect on why do so many exclusively quantitative techniques fail the test of time. Most of us have seen it over and over again. People doing highly sophisticated counting work, little dimples in the polish, count the striations, measure the striations in depth, and you see 1 or 2 publications, and then never again. first and foremost, we are archaeologists. Archaeologists are anthropologists of the past. We are telling a human story, and we are looking at material generated by humans. And when we take those variables out completely, our story becomes weakened for the human story. But that's just my opinion. So yes, let's do the quantitative work as best as we possibly can, but let's never forget that every person is going to run differently, thrust differently, play differently. And that is what we see in the end on our tools. Very good work of Ala Jarosevic, and it came very timelessly for a colleague and me that were working on some issues. Also followed an integrated approach, fractures and microwear. And back to my own hunting story. Some of you might be familiar with that publication, Bows and Arrows, 64,000 years ago. That created a bit of a hoo-ha. And actually, that paper was born out of skepticism. Laurel and I thought, no ways, there's no arrows by that time in Africa. And we were not confident that we will be able to figure out how to differentiate between spears and arrows. But in the end, based on morphological work and ethnographic evidence, we needed to test the hypothesis that if a transverse hafting position, impact use, and contact with animal material can be confirmed on the very small quartz segments from Sibudu, there's almost no other interpretation as that being used as an arrow tip. So first, we looked at the fracture damage, and we directly compared it with the work of Jarosevic, and specifically halved it in the position that we think might or may not be. And our fractures were very similar to what they found on transversely hafted pieces that were used as arrowheads. And when I took a closer look, this is one of the things that I saw. You can see impact damage here, transverse striations, bone residue. And when the residue stops, the striation stops. The bone slides over and it's not in direct contact anymore. I know the direction of impact, I know what it impacted against. Animal tissue. If we look carefully, we can see a nucleus here, perhaps even there in the animal tissue. And you can also see how the animal tissue is smeared in a very specific direction from the edge of the tool to the inside of the tool in a transverse direction. What I believe to be blood, and perhaps even a crenellated blood cell that has the right measurements, might be a ghost blood cell, nonetheless. And some resin, thick resin deposits, and in the resin, imprint of plant cells in a transverse direction. Plant cells only grow one way. So if I have it in a transverse direction to my tool, there's only one way that that half could have sat onto the tool. So, on a very small sample, the impression is that it was hafted this way. This is an archaeological example, 2,000 years old, from Adamskrans, excavated by Johann Bennemann. It was not hafted in any of these ways, or like the Australian death spear. For the same time, in the same context, Lynn Wadley has published evidence of snares being used. And here you can see the concept of the energy, latent energy in a bent branch, and the ability of people to make rope with a tensile strength that would be enough to make bows with. Same time, same context, 64,000 years ago. We also have bone tools. These are historical and ethnographic bone points, and morphologically, the bone points from Sibudu is similar to the arrow points, unpoisoned arrow points of bushmen in South Africa during ethnographic times. Experiment with another Justin Bradfield student, used replicated bow and tool, shot it with a bow and arrow, and the fractures on the butt is the replicated fractures. This is the Subudu tool. So it's not conclusive. Fractures are never conclusive, but it's consistent. So having done that experiment, at least we cannot eliminate possible arrow use for the bone point at Subudu at the time. So at that time we had circumstantial and limited based evidence of bow and arrow use 64,000 years ago in South Africa. But me being a skeptic had to go and test again. Give me all the little cord segments. I want to see them all. 16 were excavated subsequently, counted 1,039 use traces on them, and at least 50% of that showed use trace sets consistent with what is expected of transverse after arrowheads. See very clear transverse striations at the back side. That's probably from hafting. Transverse striations, the top there, on the edge. The edges are sharp, they're not rounded, but they do have damage, and these striations, and all kinds of residues together with that. Now, what about Shay's major issues? We all know that humans don't hunt, are not exclusive in hunting with animals anymore. But we are the only ones to make our weapons with other tools. And that means we have increasing possibility to look at chain of repertoire and problem solution distances in our technologies. This is the work of Miriam Heidler in Germany, and what I'm showing you in the next couple of slides is work that's in press at Cambridge Archaeological. Don't try to read this. Don't try to understand it, okay? It's not. The only thing that this represents, it's a thought and action sequence, and it means if I want to make a fire, I have to think about how I'm going to make a fire, what I need, and I need to start collecting it and do all kinds of things to reach my goal to make a fire. So it's just a symbol of these thought and action processes involved in a single task. Now, when we look at the Schöningen spears, simple wooden spears, we see that at least 4 of these thought and action sequences have to fall in place before we can take our spear and go hunting. Now this shows us that there's already an increase in time depth and complexity and problem solution distance compared to using just a stick, even if I sharpen it with my teeth a bit to go hunting. It also shows us that the intermediate aims and satisfactions is starting to separate from my basic need. I'm hungry, but it's not necessarily just, as Michael showed us, I take the stone, I focus on it, and I pound my nut, and I have my stone, and I'm satisfied. I have to make different tools and sometimes fire, and I can save these tools for a next day, and I can build fire several times during the process of this kind of thing. And we believe that this is conceptual and behavioral modularization, where our minds can start to separate certain tasks from each other to reach a goal somewhere in the future. Now, we will probably never know where, how often, when hafting was invented and reinvented by populations over time and space. But what we do know is that it radically changed hominin technology forever. And to make a stone-tip spear, many more thought and action sequences have to fall in place before I can go a-hunting. And it also shows a new cognitive component of composition and therefore advanced modularization. My mind understands now how to put two completely different materials together and make something with properties that neither of them had on their own. And if we compare that directly to the stone of the wooden spear, Schöningen spear, we can see a considerable increase in the planning, the problem solution distance when we start talking about advanced materialization. And of course, it makes us so much more flexible in our environment. It's quite a different story when I have tools like this and when I have just a straight stick and a handful of tools. I interact with my environment completely differently. But we know we share these things with other hominid species, such as Heidelbergensis, Neanderthalensis, early archaic humans. But convincing evidence for mechanically projected weaponry is thus far exclusive to Homo sapiens. And I think that also includes the use of archaeological. And to make and use a bow and arrow, there are many, many more thought and action sequences that have to fall in place before I can reach my goal, satisfy my hunger. But when we looked at these separately, either the bows or the arrows, even with our rather complex arrows, we were not convinced that on a cognitive level they were any different from any other composite tool. However, the minute that our mind starts focusing on them together, something else might be happening. And this we are now calling the cognitive component that's represented in symbiotic technologies. It means that simultaneously and actively, I'm not just holding something, I'm actively manipulating and focusing on two different technologies to reach a goal that I cannot possibly reach with either of these technologies on their own. And even then still focusing on the running antelope somewhere in the distance. And we are at the moment calling that amplified modularization, when humans can start putting different technologies together. And here you can just see how the volume of thinking and action increases with these different technologies. And bow arrow hunting also has niche broadening advantages. It can be used in the biggest forests, driest of desert landscapes, to hunt animals on land, animals in the treetops, whether it be birds, monkeys, and on the water. It possibly revolutionized interpersonal aggression and warfare. And for me, the most important is, from an evolutionary perspective, it is a lightweight, portable system providing a single person with multiple shots that can be delivered in quick succession into an array of target types from a distance and a concealed position. And no other Stone Age weapon system allows this configuration. It permits an individual to accomplish alone what can only be done in a group or at great risk using hand-delivered weapons. Hunting with bow and arrow is thus not only niche broadening in terms of prey type and landscape, it also increases the fitness profile of a single person or a small core family group. And some of us are arguing that it was probably part of a suite of strategies that provided Homo sapiens from Africa to successfully spread across the globe. Now, once humans are able to understand symbiotic technologies, different technologies can be combined in all kinds of different ways, even to make music with, and is still being done in Africa today. And this shows us that now our minds are able to to string along unlimited sequences, different technologies, to reach goals that could be very complicated. And it doesn't matter if it's just a very simple thought and action process, but by stringing these into sequences, we can create technologies that we can explore space today. And this is all because some of us are taking the time to really understand what happens in small stone tools around us. Someone sat 64,000 years ago, made that, used that, and all of us in this room make it our business to understand what's happening on that. And by doing that, we can even answer old Uncle Screwtape now and then, or at least try to. I thank you.